All right, this one is another example, and it says just set up, which is like one of the quiz problems. It also is going to be a little bit more complicated than the quiz problem. On both quiz problems, we have rotating around the y or the x-axis, and decided to do some examples where you rotate around something else, rotate around line y equals x equal to 2 here. So this one says find the volume is the region bounded by y equals x cubed, y equals 0, x equal to 1, and rotated around the line x equal to 2. And we're just going to set it up. So get the picture going here. Here's y equals x cubed. Of course, it also goes that way, but it says that we're going to also bound it by y equals 0. That's the x-axis. And x equal to 1. So pick a spot here to call 1. So there's the region inside of there. This is another one where it's either type 1 or type 2. It's both types. So you can pick and choose. And just for the case of, just for the sake of having a cylindrical shell problem, I'll pick it to be type 1 so that when I rotate it around a vertical line, x equal to 2, it will give me cylindrical shells. So here's x equal to 2. So this is rotating it around a different vertical line, but it's just like the y-axis. It's just vertical line in a different spot. So when you rotate it around that, you'll get circles that look like this. Another one down here, and then a bigger one. That's not perfect, but close enough. It's a big funnel shape with a hollow center cylindrical core there. And so if I'm going to do it as type 1, so this is a decision that I made. I could do it type 2 and get the same answer. In fact, on a test question, I'll either have examples where only one of the types can possibly work, or I could tell you that you have to use type 1 or type 2. Type 1 is a little bit easier typically because it's the one where you get to use dx. So there's the type 1 slice. All right, now I think I'll show that rotated around the line x equal to 2 over here. So here's that same vertical slice, and here it is. What happens when you rotate it? Makes a big circle or ellipse from this point of view, and there's the rest of it. Yeah, it could be. You can see some of that, and I'm rotating it around this vertical line. That's x equal to 2 right there. It's the same as this dotted line over here. I just made it solid on this picture. So that will change how I find my radius. Usually when I'm doing a cylindrical shell like this, I find the radius by using a vertical line in the case of using a type 1 around the y-axis, and the radius is just the distance to 0. But this time the radius is the distance to 2. And here's my x value here. I better put an x on this underneath the slice, because my slices are going to go from 0 to 1. That's how I slice up the region. And so the x value is anything between 0 to 1. I could start the integral already by saying it goes from 0 to 1. If I put the integral down here, I know I want x to go from 0 to 1. And so what is the distance from here to, from x to 2? I need this radius. So that's my x, and there's my 2. So the distance from x to 2, it'll start out as being the distance from x to 2, if I'm all the way at x equal to 0, would be 2. It's the distance from the larger number minus the smaller, and x is staying smaller. It goes from 0 to 1, so it's going to be 2 minus x. That's my radius. So when I set up this integral, my dv is usually, I remember how you do this, you slice it open and roll it out flat. So when you slice it and roll it out flat, you get a big rectangular solid, and the height, it will be the same height as the other one, which is going to be x cubed, and the length is going to be the circumference of the cylinder. So the length of that is going to be 2 pi r, but 2 pi r will be 2 pi times 2 minus x. So yeah, if it was rotated around the y-axis, the usual vertical line, then it would just be, the radius would just be x, because I would do x minus 0. But since I'm rotating around this line over here, I have to figure out the radius is going to be 2 minus x, the distance from x to 2 every time. And then the thickness of it is dx. Put a dx there. And so dv is going to be the 3 dimensions of that rectangular solid, the rolled out cylinder, that has the circumference 2 pi times 2 minus x, and then times the height, x cubed, times the thickness. So it'll be, I'll put it here, 2 pi 2 minus x and x cubed and dx. So for your problem in the quiz, it's not as complicated as that. All you would have here would be, if it's this shape of cylinder, if we were doing this problem rotated around the y-axis, that would be an x there. But you do need to be able to figure out where the radius is coming from. So that goes into the volume, and there's the final answer for this. 2 pi 2 minus x, x cubed, dx. This is a very easy integral to do. You just have to multiply the x cubed through. You can pull the 2 pi out, and then you can raise and divide the x cubed. So you'll get an x to the 4 over 4, and you'll get an x to the 5 over 5. And I'll let you finish that part. It comes out to 3 pi over 5. Okay, but this was the answer because it said just set up. You didn't actually have to do the integral on this one. So that would be the final answer in the box. All right.